Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. Now make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 24 minus 1. Now, 2 to the power of 24, this is the same thing as 2 to the power of 12 times 2 minus 1. And now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, 2 to the power of 12 times 2, that's the same thing as 2 to the power of 12 to the power of 2. Now I have this minus 1. Now, we know that 2 to the power of 10 is equal to 1024. So 2 to the 11, this is equal to double of 1024, which is 2048. And finally, 2 to the power of 12, this is going to equal double of 2048, which is 4096. So now I have 4096 squared minus 1. Now, 4096, this is the same thing as 4100 minus 4. So I have this squared minus 1. And if I have something in the form a minus b squared, this is equal to a plus b times a minus b. So 4100 minus 4 squared minus 1, and 1 is the same thing as 1 squared. So now this is the same thing. Sorry, it's not a plus b times a minus b, it's actually a squared minus 2ab plus b squared. So we have 4100 minus 4 squared. So this is going to equal 4100 squared minus 2 times 4100 times 1, or sorry, times 4 plus 4 squared. Now 4100 squared, that's going to be 1,681,000. Sorry, 16,810,000. Now I have this minus 32,800 plus 16, and then we can't forget our negative 1 at the end. So now all of this is going to equal 16,777,200 plus 15, which is equal to 16,777,215. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So I have 2 to the power of x is equal to 20 to the power of 10. So the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 20 to the power of 10. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, log 2 to the power of x, I can move x to the front, and log 20 to the power of 10, I can move 10 to the front. So now I have x times log 2 is equal to 10 times log 20. Now, if I divide both sides by log 2, these two cancel out, and now I'm left with x is equal to 10 times log 20 over log 2. Now log 20, I'm going to rewrite that as log 10 times 2 over 2. And now if I have something in the form log a times b, simply equal to log a plus log b. So in this case, log 10 times 2, that's going to equal log 10 plus log 2. Now I have this over 2. Now, if I distribute the 10, I get 10 times log 10 plus 10 times log 2 over, sorry, this is actually log 2, not 2. And now This is the same thing as 10 times log 10 over log 2 plus 10 times log 2 over log 2. Now, log 10, that's actually equal to 1. So now I have x is equal to 10 over log 2 plus 10 times log 2 over log 2. And these two log 2's are actually going to cancel out. So now I'll be left with x is equal to 10 over log 2 plus 10. Now, log 2, this is equal to 0.301. So now I have x is equal to 10 over 0.301 plus 10. And 10 over 0.301, this is equal to 33.2226. Now I have this plus 10. So now this is the same thing as 43.2226. So this is my answer. Alright, so in this problem, I have 2 to the power of 19 minus 2 to the power of 18. So for my solution, first start with 2 to the power of 19 minus 2 to the power of 18. Now, 2 to the power of 19, this is the same thing as 2 to the power of 18 plus 1. So now I have 2 to the power of 18 plus 1 minus 2 to the power of 18. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 18 plus 1, that's going to equal 2 to the power of 18 times 2 to the power of 1. And I have minus 2 to the power of 18 at the end. Now from here, I can go ahead and factor out 2 to the power of 18. So I have 2 to the power of 18 times 2 to the power of 1 minus 1. Now 2 to the power of 1, that's simply equal to 2. So I have 2 to the power of 18 times 2 minus 1. And 2 minus 1, that's equal to 1. So now I have 2 to the power of 18 times 1. Now 2 to the power of 18 times 1 is simply just 2 to the power of 18. So I'm simply left with 2 to the power of 18. Now, although this is a solution, I'm actually going to find a way to simplify this. So 2 to the power of 18, this is the same thing as 2 to the power of 9 times 2. And if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 9 times 2, that's going to be 2 to the power of 9 to the power of 2. Now 2 to the power of 9, this is equal to 512. So I have 512 to the power of 2. 512, I'm going to rewrite this as 500 plus 12 to the power of 2. Now this is the same thing as 500 plus 12 times 500 plus 12. So to solve this, I'm going to first start by distributing the 500. So now I have 500 times 500 plus 12 times 500. Now if I distribute the 12, I have plus 12 times 500 plus 12 times 12. Now 500 times 500, that's going to be 250,000. Plus 12 times 500, that's going to be 6,000. Plus again 6,000. Plus 144. Now 6,000 plus 6,000 is 12,000. And 12,000 plus 250,000 is 262,000. Plus 144 is 262,144. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 3 minus x squared equals 100. Now, what we're first going to do is, as you can see, both of these terms have x in them, right? So the best thing to do is to factor out x with the highest degree, which in this case is 2. So we're going to factor out x squared. And that would help us simplify our equation by a lot. So if we factor out x squared, x to the power of 3 divided by x squared, well, that's x to the power of 3 minus 2, which is x, because x to the power of 1 is x. minus x squared divided by x squared is simply 1. So we have x squared times x minus 1, and this equals 100 still. Now what we're going to do is we're going to change 100 into 25 times 4. 100 is equal to 25 times 4. And this is still equal to x squared times x minus 1. Now this gives us two equations. We would have x squared equals 25 and x minus 1 equals 4. Well, for x squared equals 25, if we do the square root on both sides, we would get, well, the square root of x squared is simply x equals, the square root of 25 is positive or negative 5. So as you can see, this is one solution, and x minus 1 equals 4. Well, we would add 1 on both sides, and if we do that, we get x, these two cancel out, equals 4 plus 1 is 5. However, as you can see, 5 is already one of our solutions, so this is just unnecessary. We already have this as a solution. So we have x equals 5 and negative 5. Now, why don't we plug these two into our equation and see if they are right? Let's first start with 5. So we would have 5 to the power of 3 minus 5 squared equals 100. Now, this would equal, well, 5 to the power of 3 is 125, and minus 5 squared is 25, and 125 minus 25 is 100. So 100 equals 100, and this is right, so 5 is a solution. Now, why don't we plug in negative 5? Plugging in negative 5, we would get negative 5 in parentheses to the power of 3 minus negative 5 to the power of 2 equals 100. Now, negative 5 to the power of 3, well, a negative to the power of an odd number is still going to be negative. And 5 to the power of 3 is 125. So this would be negative 125 minus negative 5 squared is 25. And negative 125 minus 25, well, that's negative 150. And that is not equal to 100, so this is rejected. And 5 is our only correct answer.